Marita, am I audible?
Sir, can you hear me?
Yes, I can hear you now. Sorry, I was facing some technical glitches. So, okay, let's discuss your doubts. Your first question is, okay, this is your first question. Okay. So this is the support. From the support, this is weight W1. This is pulley. This is W2. So the system is in equilibrium. You're supposed to calculate the ratio of W1 and W2. See, so you have two strings. Two strings means you'll be having two tensions. So in this string, let's say tension is T1. In this string, let's say the tension is T2. And these angles are given, right? How much is this angle, Marita?
So 53 degree.
This is 53. And this angle here,
37 degree.
37 degree. So it's a classical problem of equilibrium. Huh? This is 37 degree. It's okay. Now, if I consider this W1s, this point here, so three forces are acting over W1. First is weight, which is acting in the downwards direction. Second is T2, and then is T1. Just resolve T1 and T2. So the component of T1 in this direction will be T1 cos 53. And the component of T2 in this direction will be T2 cos 37 degree. Similarly, we can take components of T1 and T2 here also. So this will be T2 sine 37. And it will be T1 sine 53 degree. So the net force which is acting in upwards direction is equal to net force acting in downwards direction. So you can write T1 cos 53 plus T2 cos 37 will be equal to the weight W1. So next what we can do is this first equation, and then you can equate these two things also. No? Left hand side and right hand side, these forces will be equal. T1 sine 53 will be equal to T2 sine 37. So these two forces are equal. This is second equation. Similarly, if we take equilibrium W2, the W2 it's easy. See, this is T2, so this tension will also be T2 because it's single string which is going over the pulley. And this is weight W2. So here you can write T2 is equal to W2. This is equation number 3. So what you can do is you can you need the ratio of W1 and W2. So W2, you know it's equal to T2. Next, you need W1 in terms of T1. So from here, you can substitute T1 in terms of T2 and then substitute the value of T1 here. So we'll have both W1 and W2 in terms of T2 and then you can take ratio. Yes, Marita, is it clear now?
Yes, sir. So for this question, we should know what sine 53 and
yeah. That you should know. Like cos 37 is 4/5, fine. And sine 37 is 3/5. This you should remember. Cos 37 and sine 37. And if you know cos 37 and sine 37, you can easily calculate 53, right? So you can do this thing. Sine 90 minus 53, you can write 90 minus 37. This will be cos 37. Fine?
Yes, sir.
So this is it. Okay, Marita, the rest of your questions discuss at the end of the class. Let me start the class now. Just give me 2 minutes. I'm starting. Hi, I'm audible.
Yes, sir.
Sorry, I'm facing some technical issues. Like I am not able to write here. Anyways, so in the last class, we have finished up to the specific heat at constant pressure and specific heat at constant volume. So there are two new students. Ashrit, your first class with me? And Rehan.
Yes, sir.
Okay, so in this class, we have started like KTG and thermodynamics both. In the previous lecture, we have discussed thermodynamics and we have discussed up to the first law of thermodynamics, right? We also have discussed that thing, na, like isothermal and the second type of process, isochoric and isobaric process we have discussed. Yes.
Yes, sir.
Okay, so we have discussed about isochoric process we have discussed, isobaric process we have discussed. Now we'll start with the isothermal process and the adiabatic process. So CV we have finished. Okay, so let's start with the isothermal process. So isothermal processes are those processes which are at constant temperature. If temperature is constant, then the process is known as isothermal process. The first thing about isothermal process is temperature will remain constant. Temperature is constant, that means change in temperature will be zero. For isothermal process, the temperature will remain constant. The temperature can only remain constant if the walls in which the system, in which the process is ongoing, the walls should be conducting. If the walls are non-conducting, then your process cannot be isothermal process. The reason is what type, like what could be the process here? There can be two type of process. You take this container, you case some gas in the container. Gas can either expand or your gas can compress. If gas expands, then it usually cool down. So if it gets cooled down, that means temperature will decreases. But for isothermal process, you want temperature to remain constant. So what we do is we take this gas in a container which have conducting walls. So when it expands, we provide some energy, external energy, so that temperature remains constant. The same thing is when you compress this gas, then also when you compress the gas, then the part of work done get converted into internal energy. So the temperature can rise, but you want temperature to remain constant. So what will happen is when you compress the gas, walls should be conducting so that the heat generated can come out of the system. So for isothermal process, your walls should be conducting walls. Your walls cannot be non-conducting. The next is the process should be very slow because heat exchange is a very slow. It takes time. So the process should be slow to exchange heat. When we use first law of thermodynamics here, first law of thermodynamics says delta T equal to 0, delta U equal to 0. This is delta Q is delta U plus delta W. Delta U is 0, so you can write delta Q is equal to delta W. Next, the expression of work done here, no need to do this derivation. This is the expression of work done. It's nRT 2.303 log of V2 by V1. N are the number of moles. R gas constant, T is temperature of the system, V1 and V2 are initial and final volumes. Then we need equation of state. So for isothermal process, this is the equation of state, PV equal to constant. Or you can write this as P1 V1 is equal to P2 V2. Then you need specific heat. We already did specific heat in the last class. Specific heat is heat divided by M into delta T. So for this particular process, delta T is 0, means the term in the denominator is 0. So this will be 1 by 0, which is infinite. So specific heat will become infinite. So C is equal to infinite. So that is about isothermal process. Now, if we want to plot, okay, we'll do one numerical, then we'll plot it. Just note it down. Aditya, you were absent last week. What happened? Aditya Garg. Please note it down. Adriel, Pradarshini, written. Can I scroll it down?
Yes, sir.
Yes, sir.
No need to write the complete derivation. Just write the final expression of work. Yes, written everyone?
Yes, sir.
Yes, sir.
Okay. So let's start with a very basic numerical, but for the numericals of isothermal process, you should have some basic idea about log. So you should remember these values. Log 10 is 1, log 1 is 0, log 2 is 0.3010, log of A into B is log of A plus log of B, log of A to the power n means n log A, log A minus log B is log of A by B. Just note down these results. I know you all have maths, you should be aware of it. Aditya, am I audible? Ashrit, can you hear me? Sure. So let's do this quick question. Yes, everyone have written up to here? Pradushini, written?
Yes, sir.
Okay, Aditya. So let's do this quick question. An ideal gas is compressed to half of its initial volume slowly if initial pressure and temperature are 180 m and 300 Kelvin. Calculate the final pressure and temperature. So see, usually in questions of isothermal process, it's not given whether the process is isothermal or not. So through the language, you have to decide whether the process is isothermal or not. So if it says slowly, this slowly will tell that the process is isothermal. So if it is isothermal, that means temperature will remain constant. You need final pressure. Initial pressure is 180 m. So Rehan, what was the equation for isothermal process that we wrote just now? Krishna, what was the equation for isothermal process?
P1 V1 is equal to P2 V2.
P1 V1 is equal to P2 V2. So how much is P1? P1 is 180 m. Volume is V. P2 you are supposed to calculate. V2 is, what's the final volume, Marita? Marita, what's the final volume? It compressed to half of its
the
initial
initial.
volume. So V2 is V by 2. You can just cancel them out. And you will get that P2 here. P2 is equal to 1 into 2. So P2 is equal to 280. So the pressure will get doubled. Okay, now if I asked about this thing, the final temperature, see the final temperature is same as that of initial temperature because the process is isothermal. In isothermal process, temperature does not change. So if initial temperature is 300 Kelvin, the final temperature will also be 300 Kelvin. Pridarshini, what is the expression for work done? How will you calculate work done in this process?
Using the equation nRT into 2.303 log V2 by V.
So work done is 2.303 nRT log of V2 divided by. So see, we have all terms. Huh? R, we know. What's the value of R? Gas constant. Rehan, what's the value of gas constant here?
8.1.
Number of moles.
8.314.
Yeah, 8.314. Number of moles is not given in question. That means number of mole is 1. If it is given, we'll take it. R is 8.314. Temperature is 300 Kelvin. Log of V2 by V1. V2 is V by 2. V1 is V. So this V will cancel this V. This will be log half. So log half you can write as log 1 minus log 2. This is log half. So you can write log half as log 1 minus log 2. So this will be 2.303 8 3.14 8.3. Log of half, so that is log 1 minus log 2. So log 1 is 0 and log 2 will be 0. We have already written 0.3010. So you can calculate work done from. Just note it down. We'll do adiabatic process and then we will come to the numericals. And we'll see what type of numerical you can get in PY.
So if number of moles is not given, we have to take always as 1.
Yeah, if number of moles are not given, then just take it to be 1.
So can you show the question as well?
Yes.
Done, sir.
So I'm not putting the value of log 1 is 0, log 2 is 0.3010. I'm not substituting the values. You can do that. The next is you can draw graph for isothermal process. The first one is PV graph, volume and pressure. See, in isothermal process, both pressure and volume will change. So if you draw PV graph will be like this. It will be hyperbolic. You increase volume, pressure will keep on decreasing. Then you can draw PT graph. Rehan, can you guess the nature of the PT graph? Rehan, the nature of the PT graph for isothermal process. Temperature will change or it will remain constant? Rehan. It will remain constant. Huh? So what should be the nature of the graph?
Straight line.
Straight line, perfect. So pressure will keep on changing, but temperature is not changing. So the graph will be a straight line. Next, if I ask you to draw volume versus temperature graph, this is temperature and this is volume. What will be the nature of the graph, Priyadarshini?
It would also be a straight line.
Straight line. So in all process, you should be able to draw these three types of graph, PV, PT, and VT. Now, throughout this graph, pressure and volume are changing, but since the process is isothermal, that means your temperature will remain constant. So from this graph, you get an important type of question. It will draw three isothermal graph. Huh? It will draw three isothermal. And it will ask, okay, in which graph the temperature is higher? So since in PV is equal to nRT, for a single, let's say for this graph, temperature is T1. For this graph, temperature is T2. For this graph, temperature is T3. And as you go on, if you go in this direction, then you have to decide whether T1, T2, T3 are increasing or they are decreasing from T1 to T3. So what you can do is you can see from here that T is directly proportional to T. So as you go up, pressure is increasing. That means temperature is increasing. So T3 is greater than T1, T2, which is further greater than T1. So this is how you can decide temperature if you have a number of isotherms. I'm repeating again. This is isothermal graph. So for a single graph, temperature is constant. Now there are three isothermal graphs. So in each of the graph, individually temperature is constant. For the first graph, temperature is T1. For the second one, it's T2. For the third graph, it's T3. Now you have to compare T1, T2, and T3. So how will you compare? T3 maximum temperature, then T2, then T2. So the temperature T3 is the maximum. After this, and these graphs are also known as isothermal. There is one more thing. They can ask you to calculate the slope of the graph also. So for the slope of the graph, PV is equal to constant. This is the equation. So from this equation, you are supposed to calculate slope. So to calculate slope, what we can do is we can differentiate this equation. See, you have P and V, so we'll be using product rule. The differentiation of P is 1. Then instead of P, you will write dP into V plus derivative of volume is 1. Then it's dV and P is equal to the derivative of constant is 0. So you can write dP by dV and that will be equal to minus of P by V. So this is the slope of the graph. So the slope of the graph is this dP by dV, which is minus of P. So that is about isothermal process. Note it down. See, in thermodynamics, graphs are very, very important. Note it down. We also have to learn how to convert one graph into another. Yes, written.
Yes, sir.
Yes, sir.
Okay, perfect. So the next process is adiabatic process. So Pradarshani, do you remember what is adiabatic process? Okay, I opened the slides also. Okay. So in adiabatic process, heat remain constant. Means no heat can enter or leave the system. This is possible only if the walls are non-conducting. So in adiabatic process, delta Q is equal to 0. Heat is constant, non-conducting walls. But remember, you don't have ideal walls. Like you can't have any wall which is ideally non-conducting. So what we do is we keep the process to be very fast, because to exchange heat system needs some time. But if you take a very, very fast process, then system will not get enough time to exchange heat with the surrounding. So system cannot exchange heat with the surrounding and the process will be adiabatic. So adiabatic process should be a very fast process. The equation of state is PV to the power gamma is equal to constant. P1 V1 to the power gamma is P2 V2 to the power gamma. So here you will be using like the kinetic theory of gases. Gamma is the ratio of Cp and Cv. And there is one more relation for gamma. Adriel, do you remember relation of gamma in terms of degree of freedom? Marita, this was the relation gamma F plus 2 by F.
Yes, sir. 1 plus 2 by.
F plus 2 by F, right? That was the formula for
Yes,
gamma,
sir.
where F is the degree of freedom. And in adiabatic process, see, all three variables are changing. Pressure will change, volume will change, temperature will also change. So this is the equation between pressure and volume. This is the relation between temperature and volume. Tv to the power gamma minus 1 is constant. So T1 V1 to the power gamma minus 1 is T2 V2 to the power gamma minus 1. This is another equation. And this is P to P and T. So this relation is in between pressure and volume. This is in between temperature and volume. This is in between pressure and temperature. P to the power 1 minus gamma, T to the power gamma is constant. When we talk about specific heat of adiabatic process, specific heat is delta Q by M delta T. So delta Q is 0. That means C will be 0. Next is first law of thermodynamic process. For the first law, delta Q is delta U plus delta W. In the adiabatic process, delta Q is 0, so delta U is equal to minus of delta W. So if delta W is for expansion, then delta U will be negative. So if the gas is expanding, W work done is positive, so change in internal energy will be negative. Change in internal energy is negative, that means temperature is decreased. For work done, we have these two relations. One is this, P2 V2 minus P1 V1 by 1 minus gamma, and this relation. NR T2 minus T1 by 1 minus gamma, where T1 and T2 are initial and final temperature, gamma is the ratio of Cp and Cv. Note it down, then we'll draw some graphs for this process and then we'll proceed. Rehan, are you getting these things? Because I'm going bit fast. I have discussed many things in the previous class. Are you following the lecture?
Yes, sir.
Has it written? Can I scroll it down?
Yes, sir.
Yes, sir.
Adrian?
Yes, sir.
Okay. So everyone have written up to here?
Yes.
Sure. So this is a similar question. This is just will match with the one that we did for isothermal process. You have a 1 mole of an ideal gas. It's compressed to half of its initial volume. Say adiabatic is not mentioned, but suddenly means process is fast. That means it should be adiabatic. Initial temperature is 400 Kelvin. Initial pressure is 1 atm. You're supposed to calculate the final pressure and the final temperature, and also the work done. Gamma, you don't need gamma. It's written that gas is monoatomic. Monoatomic gas. The gas that we have here is a monoatomic gas. So what is the degree of freedom for a monoatomic gas, Adrian? F. Adriel, what's the degree of freedom for a monoatomic gas? We finished this thing on Thursday.
Sorry, sir, I didn't hear you.
I'm saying, what is the degree of freedom for a monoatomic gas?
Monatomic gas is 3.
3. So degree of freedom for a monoatomic gas is 3. And what is the expression of gamma for F degree of freedom? Yeah, what was gamma if degree of freedom is F? It was F plus 2 by F, right? So for a monoatomic gas, your degree of freedom, this gamma will be 3 plus 2 by 3. So that will be 5. Now please solve it and get the value of final pressure and final temperature. Solve this equation and get the value of final pressure and final temperature. And write your answer in chat. So equations you have, initial temperature you have, initial pressure you have equations, just solve it. Answers, at least write the answer of final pressure. Your answer, in your answer, you may get powers in terms of fraction, you can leave it there only. If you're getting powers in the form of fractions, leave it in the form of fractions. Okay. I got one answer from Adriel. Krishna, Marita, Priyadarshini, Rehan. Aditya, your answer. Okay, so let's solve. Okay, got answer from Krishna also. Marita, Priyadarshini, Rehan. So see, this is the equation P1 V1 to the power gamma is P2 V2 to the power gamma. P1 is given as 180. V is V to the power gamma. P2 final volume is V by 2, so it's V by 2 to the power gamma. So see, V to the power gamma and V to the power gamma gets cancelled out. You have P2 is 2 to the power gamma. And your P2 is 2 to the power, gamma is 5 by 3, so it's 5 by 3. And answer is in 8. This is final equation. Marita, Priyadarshini, is it clear?
Yes, sir.
Okay. The next is this. Next, you want temperature. So you need a relation between temperature and pressure, or volume and temperature. I believe this will be the best relation. TV to the power gamma. So you can write T1 V1 to the power gamma minus 1 is equal to T2 V2 to the power gamma. So from here, you need a T2. So you can write T2, or it's write the value of V1 and V2 first. Many terms will get done. So this is T1. Volume V1 is V, so it's V to the power gamma minus 1. Then this is equal to T2. Volume V2 is V by 2 to the power gamma minus 1.
Sir, isn't the initial pressure 10 atm, atm?
Initial pressure was what? 1 atm.
Okay, okay.
So this V to the power gamma minus 1 will cancel this V to the power gamma minus 1. And you will get that your T2 is, it's T1, which is this one, 400 Kelvin. Multiplied by this 2 will go to the left hand side, 2 to the power gamma. You can just substitute the values. It's 400 into 2 to the power gamma minus 1, where gamma is 5 by 3. It's 5 by 3 minus. This. So this is how we calculate the final. Similarly, Once you have T1 and T2, then to calculate work done is a straightforward thing. Right? The work done is just nRT2 minus T1 by 1 minus T. It's no real. Rehan, is it clear?
Yes, sir.
Were you able to solve any of the part, first, second, third, on your own?
The pressure one.
The pressure one. Okay. Next, we'll plot graph for this process, each edit. Okay, after this, the next thing is graph. You're supposed
Sir, could you please show the formula for adiabatic process, the work done by?
yeah, this is the work done. P2 V2 minus T1 V1 by 1 minus gamma. And NR T2 minus T1.
Okay, sir. Thank you.
Okay, the next is graphs. So let's plot graph for adiabatic. See, the first is it's PV graph. You need pressure versus volume graph. For pressure versus volume, we're using this equation. PV to the power gamma is constant. Or you can write this as P is constant K by V to the power gamma. Now, on increasing V, pressure will increase or decrease will depend upon the value of gamma. The gamma here is greater than 1. Gamma is greater than 1, that means pressure is inversely proportional to volume. So when you increase volume, the pressure will increase. So that means the graph will be this. This is volume, this is pressure, it will. If you calculate slope of the graph, for slope of the graph, you have to differentiate this equation, PV equal to gamma is equal to K. So when you differentiate this equation, you will get dP by dV is equal to minus of P by into gamma. So if we compare the slope, this is the slope of adiabatic process. So if you compare the slope of adiabatic process with that of the slope of the isothermal process, here in adiabatic case, slope is greater. That means the change is steep, steeper than the isothermal. So it's minus P by V into gamma, the slope is steep. I asked you to pick which one is isothermal and which one is adiabatic. So the one which have smaller slope is isothermal, and the one which have larger slope is adiabatic. Or you can say one which have which is less steep is isothermal, and which is steeper, that is adiabatic. So if we compare these two, so I call this as 1 and I call this as 2. Rehan, can you pick which one is isothermal and which one is adiabatic?
First one is isothermal.
First one is isothermal and second one is adiabatic, because this have smaller slope than this. This is steeper. So the steeper one is adiabatic, and the one which have smaller slope is isothermal. So that's first graph. Next, we need to draw P versus T graph also. So what was the relation between pressure and temperature, Krishna?
Directly proportional.
No. Adiabatic process are we talking about? Relation between pressure and temperature in adiabatic process. There was one equation. Marita, what was the equation between pressure and temperature?
Sir, P raised to 1 minus gamma into T raised to gamma is equal to a constant.
So now you have to plot this graph. To plot this graph, you can do this thing like you can keep P to the power 1 minus gamma here. That's just K. You can bring T to the power gamma. Now you have to plot this graph, P versus T graph. So to plot this graph, you should at least know, like on increasing temperature, what happened with pressure? Pressure will increase or pressure will decrease. For this, you can bring this 1 minus gamma power to the left hand side. So Adriel, if I remove this 1 minus gamma power, what will come to the right hand side? I want to remove this 1 minus gamma from the LHS. What will happen to the right hand side? Adriel?
1 by 1 minus gamma.
Yeah, so that will be K to the power 1 divided by 1 minus gamma. Divided by T to the power gamma by 1 minus. So see, this will not matter because this is just a constant, but this will matter. Pradarshini, this gamma by 1 minus gamma, gamma is greater than 1 always. This will be positive or it will be negative. Pradarshini, I'm asking gamma is greater than 1, so gamma divided by 1 minus gamma. This will be a positive term or it will be a negative term?
Will be a negative term.
Sorry?
It will be a negative term, sir.
It will be negative. So this term is negative. This term is negative means if you have to bring it to the numerator. So this is some k constant. I'm not worried about this k, so I can write this as p. I will bring it to the numerator. So when I bring it to the numerator, then there will be a negative sign. It will be gamma by gamma. So you can see that if you increase temperature, then pressure will increase. So the graph temperature versus pressure. See, in denominator, instead of negative, you have a positive term. That will mean pressure will decrease on increasing temperature. So the graph will be happening. That may happen in VT graph. We have to plot VT graph for this. So Rehan, what's the relation between V and T? Volume and temperature? Rehan, what is the relation between temperature and volume for our adiabatic process?
Don't know.
Sorry?
I don't know.
We just have wrote this thing, the starting of the adiabatic process. Just check your notes. You must have written this. The three equations we wrote now. One is pressure and volume, another is pressure and temperature, then another is temperature. Check please. Pradarshini?
T into V raised to gamma.
Yeah, TV to the power gamma minus 1 is equal to. Or you can write that T is equal to its K by V to the power gamma minus 1. So gamma minus 1 is positive. That means T and V are inversely proportional. So when you plot T versus V graph, this is the graph will be happening. So these are the graph for the adiabatic process. For every graph, for every process, you should know at least the slope of the graph, the slope of the V. No redundancy. Rehan, those three equations now, PV to the power gamma, TV to the power gamma minus 1, T to the power 1 minus gamma, T to the power gamma, those equations are very, very important. You have to memorize.
Okay.
Note it down. Move on to the next. Just tell me once you have written. So
Done, sir.
Sir, for this graph, do we not look at the negative and positive for gamma minus 1?
no, that will not matter. The thing that will matter is whether your gamma minus one is positive. Yeah, that will matter. Na. Gamma minus one is positive. So it will remain in denominator. That's why I'm saying on increasing V, T will decrease. But if gamma minus one comes out to be negative, that means you have to take it to the numerator to make it positive. So that will mean T and V are proportional, graph will be a curve, like the previous. If it comes out to be negative, then we'll bring it to the numerator. Yes, written. Okay, now let's do one question from the recent PYQ. Let's see if we can attempt that question. Question. So you have 4 minutes for this question. Solve it and write your answer in chat.
So this one is JEE or NEET?
JEE. So whenever shift is mentioned, na, that's J. So J happens in multiple shifts. Marita, which process is this? We did 4 processes. Out of those 4 processes, which process is this?
So adiabatic process.
How you decide this is adiabatic?
So PV raised to
Very good.
gamma is equal to a constant.
Yeah, substitute this gamma. Okay, got one answer from Pridarshini. See, it's easy. Gamma is given. It's just one liner. Good, Marita. Adriel, Krishna. Yes. Yes, Krishna, you're correct. Adriel, your answer. She's a one liner. If gamma is given, then it's a one line. Yeah. See, it's just a one liner question. No? PV to the power gamma is equal to 3, right? So you can write, no, you don't need P, you need T. So TV to the power gamma minus 1. So T1 V1 to the power gamma minus 1, it's T2 V2 to the power gamma minus 1. So it's just like the first question of adiabatic process that we did. Huh? Then what you need, you want the ratio of T2 by T1. So the T2 by T1 is V1 by V2 to the power gamma minus 1. So how much is V1? V1 is V. How much is V2? V2 is 2V. Gamma is half, so it's half minus 1 is T2 by T. So this V will get cancelled out, it's minus half, it's 1 by 2 to the power minus half is equal to T2 by T. Or you can write that T2 by T1. If the power is negative, you can make it positive by bringing to the numerator. So it will be root. Because when 2 comes to numerator, then your power will become positive, half power means 2, so T2 by T. Clear, everyone? Good, Ryan. There is one more type of questions on this thermodynamics where what happens is they will give you one graph, one particular type of graph, and will ask you to generate more graph based on the given, for example. So I have one question. This is the question. So a PV graph is given. This is volume, this is pressure. This is the PV graph for a process. So this is isothermal. This is 1 to 2 is isothermal. Then it's 2 to 3. Then again 3 to 1. This is the one. And for this process, you have to draw PT graph and VT graph. Now let's see how to draw PT graph and VT graph using a PV graph. So for this, first of all, we'll write that 1 to 3. The graph is isothermal. It's given as an isothermal graph. So, Adriel, can you decide is there any quantity which remain constant from 1 to 2? 1 to 2? It's given that the process is isothermal. Huh? So which quantity will remain constant? Pressure, volume, temperature, internal energy, which?
Temp.
Temperature. So 1 to 2, you know that temperature is constant. So if temperature is constant, you have to decide what's the relation between pressure and volume, for which you can use ideal gas equation. PV is equal to nRT. So your P will be T by V now. So P and V will be inverse. P and V is inversely proportional. T and T is direct. Now, if we go to 2 to 3. So 2 to 3, Rehan, just look at this graph and tell me which quantity is constant when you move from 2 to 3. Sorry?
P.
P. So when you go from 2 to 3, pressure remains constant. So pressure remains constant. So this is the equation PV equal to nR. So if P is constant, that means V and T are direct. Next, let's analyze 3 to 1. So what happened when we go from 3 to 1? 3 to 1, volume will remain constant. So PV equal to nRT. So from here, we can conclude that pressure is proportional to temperature. Now, after this analysis, you can plot any graph. Let's start with, so we'll start with PT graph. So this is P and this is. So you know that from 1 to 2, temperature will remain constant. And 1 to 2, what's happening with the pressure? Pressure is increasing or decreasing? When we are going from 1 to 2, what's happening with the pressure?
Decreasing.
Pressure is decreasing. Temperature will remain constant. So that means this is 0.1 and this is 2. So it will be a straight line. So that temperature will remain constant and pressure will be constant. Is it clear? The straight line from 1 to 2, Pradarshini, Krishna?
Yes, sir.
Next, when you move from 2 to 3, 2 to 3, pressure will remain constant. And 2 to 3, pressure will remain constant. And see, pressure is directly proportional to temperature. So 2 to 3, pressure is constant, but volume is decreasing. We don't need volume. And pressure, volume and temperature are directly proportional. So if volume is decreasing, that means temperature is also decreasing. From 2 to 3, we can say that pressure is constant. But since volume is decreasing, that means temperature will also decrease. So the graph will straight line. Now we need 3 to 1. So 3 to 1, what's happening? 3 to 1, volume is constant. Pressure and temperature are directly proportional. They are directly proportional, that means graph is. So this is the corresponding pressure versus temperature graph. Marita, Priyadarshini, is it clear?
Yes, sir.
This is important question. You have one type of graph and you have to convert it into. Just like PT, you can draw one volume versus temperature graph. So 1 to 3, when you go from 1 to 2, temperature is constant. Pressure is decreasing and volume is increasing. So we need volume and temperature. So 1 to 2, temperature is constant. Pressure is increasing, but decreasing, and volume is increasing. So temperature constant, volume increasing. So this should be the graph. Now, when you go from 2 to 3, 2 to 3, your pressure is constant, but volume is decreasing. So volume is decreasing, pressure is equal to constant. And the equation is this, PV equal to nRT. So you need V and T. P is constant, 2 to 3, P is constant. So this term is constant. You can say V and T are directly. So your graph will be a straight line. So 2 to 3 volume is decreasing. That means temperature will also decrease and this will. Okay, just give me 1 second. 1 to 2, temperature is constant, pressure is decreasing, and volume is increasing. Pressure is decreasing, volume is increasing, temperature constant. So temperature constant, yeah, volume is increasing. Then from 2 to 3, what is happening? Volume and temperature are directly proportional. Volume is decreasing, so temperature is also decreasing. This is now 3 to 1. What's happening 3 to 1? Volume is constant, but pressure is increasing. 3 to 1. Volume is constant, but pressure is increasing. And pressure and temperature are directly. But you need, so if pressure is increasing, that means temperature is increasing, but volume is constant. Volume constant, increasing temperature. So if you have one graph, PV graph or PT graph or VT graph, then you can draw another graph. But obviously, you have to give MCQs. They're not supposed to draw the graph. You just have to identify which one is the correct graph. So this is the process of we identify. You have to write every time what's happening from 1 to 2, what's happening from 2 to 3, what's happening from 3 to 1. Then only you can pick the correct option. No. So, okay, after this, there is one more topic, which is again the mixture of this KTG and thermodynamics. And the topic is known as mixture of gases. Mixture of gas. So in mixture of gases, there are three things that you're supposed to calculate. One is, say you have first gas, number of moles is N1. Specific heat at constant volume is CV1. Another gas, number of mole is N2. Specific heat at constant volume is CV2. The temperature of this gas is T1. The temperature of second gas is T2. You have to calculate CV mixture or molar mass of one gas is N1, molar mass of another gas is N2. So this is molar mass. These are the number of moles. So you have to calculate CV of the mixture. CV of the mixture is simple. N1 CV1 plus its N2 CV2 divided by N1 plus N2. And when you need CP mixture is CV mixture plus R. And if you want this temperature, the temperature of the mixture, so to calculate temperature of the mixture, the method is same as it was in thermal properties of gases. It's N1 CV1 T1 plus N2 CV2 T2 divided by N1 CV1 plus N2 CV2. This is how we calculate the temperature of the mixture. It's the same relation that we did in mixture of the liquids also. If you want molar mass of the mixture, then it's N1 M1 plus N2 M2 divided by N1 plus N2. Is noted down. This mixture of gases. So when your math class today?
Sir, in 18 minutes.
Yes, written.
Yes, sir.
Okay, now note down the homework question. See, thermodynamics is an easy topic, so I'm not giving you questions from the NEET PY. You can directly solve it. So, okay, the first one is this question number 4. First homework question. These are theory. Question number 6. Question number 14, 1-4. Question number 16, 1-6. This is from 21, question number 21. Yeah, and 23. This is very, very important. If you are not able to solve it, we'll do it in the next class. 23 is very, very important. In 23, there is no direct formula is applicable here, because V is k to the power 2/3. It's property of none of the process. So it's neither adiabatic nor isothermal, nor isochoric, choric, not isobaric. So you have to derive it. This is a very, very important question. One of its type. And question number 30. Question number 30, 30. 34. The thing that we did right now, VT graph is given and you have to plot the PV graph. 34. 35. Same type.